In this project, different machine learning methods are applied and compared to find a best machine learning model to predict wine quality. A separate function file can be downloaded at GitHub, which it contains some basic functions as we learned from class, like gradient descent. Pandas library are used in this project due to its efficiency in data management. Since no mission data is dataset, this data can be used directly for machine learning. Firstly, feature engineering is applied on this dataset, where standard normalization and the pieces of theory outperforms the original data. Then, a correlation coefficient-based feature selection is also implemented. However, no obvious improvement occurs, which can be verified by visualization of the data, where most features are not linearly dependent on the quality. Perception method is also compared to softmax method, where we can see even though the mini batch outperforms full batch for perceptron, but overall the perceptron is not as good as multi-class softmax method. Thus, softmax would be used in the following sections. A pre-processing procedure is used on the dataset, where one quality less than 6, between 6 and 7, and larger than 7 are defined as bad, fair, and good respectively. Other dividing rules are also tested and will be shown later. Improvements can be found that machine learning accuracy increased to 70%. Beyond machine learning models we learned from this class, there are many other machine learning methods. Scikit-learn library implemented many machine learning models. A well-known classifier, the random forest classifier, is used as example. We can see different dividing methods have different accuracy. Obviously, binary classification had a higher accuracy than 3-class machine learning accuracy. So the one I choose as the final dividing method has not the highest accuracy. It is the most reasonable one, where good quality is a minor portion, and has a fair grade, which is better than only good and bad classification. Convergence test is performed on number of estimators with regard to accuracy. And a sample result is shown. Different major classifiers are compared on the dataset, where all default settings are used. It can be seen the random forest classifier is among the top. Two other classifiers, support vector and gradient boosting, is also considered for model improvement tests. In this project, grid search CV is used, where it did a grid search over different parameters and returned a batch set. Based on this refinement, a random forest classifier with optimized parameter is proposed to be the best machine learning model for white wine quality prediction. A similar procedure is done on the red wine datasets as well. And random forest classification has a similar effect on both red wine and white wine dataset. However, it is found that two datasets are not related to each other, which is due to the basic difference between two different wines. To conclude, in this project, both cross-based and open-source machine learning methods are used to predict wine quality. Among all methods, one random forest classification method with optimized parameter is proposed to be the best model for predicting white wine quality.